Let's just wait for a few minutes while others join. Hi, hello everyone. So I'm waiting more people join. So first, tell me, am I audible to all of you? Okay. Okay. So hello, my name Sunita Singh, and I am a core team member of DSC NSEC, and I am into web development, and I'm an ML enthusiast. So you can connect with me in the given links, right? So before we begin our today, I would like to tell that a link for a quiz will be given in the chat section below, so that you can take the quiz and appear for it. Remember, the link will be available for 1 hour only. So you will have to appear for the quiz within this 1 hour, and there will be some goodies for the winner. So just go to the link which will be, I guess, posted shortly, right? So we can begin now with our sessions. Okay, so begin. Am I still audible? I'm confused. Hi guys, can you please tell me that if I am audible or not? Voice is getting interrupted. So what can I do to impose the interruption? Okay, so let's just begin. I guess everything fine. So okay, so I need working. is this working? Please, can you tell me? Can you hear my voice a little bit clearer? Okay, so I will just begin with the presentation whatsoever. Okay, so I will start with the basic about what is linear algebra. Then a session which Ankita, she clearly statements of mathematics in machine learning. So I guess this part will be a little bit of recap of what Ankita presented. So we know how important mathematics is for machine learning, right? And we know there's a famous saying by David Joyce, which he said in answer to a question that what is the point of linear algebra? So it is said that its use, you will find its use very expensive. So I consider algebra as that 10 rupee note which we don't give much value to, yet it is a very important part of our daily life, right? Okay, so I would move further. I will consider that the that you guys already know Python and NumPy library. It's been already covered in the chapter 5. Okay, so yes, more or less the code which I will be showing is understandable by you. And so let's just move on. So I will start with the introduction to scalars and vectors. Right. So very first thing which you need to do is to forget the concepts of physics about what are scalars and what are vectors, which we learned in high school in our physics class, right? That vectors have one direction, scalars have two arrows and all of that. But here, scalars are basically numbers. Like you can see the numbers on screen, which are say 5, 1234, minus 23, 40, 36. Okay, so and what are vectors? Vectors could be simply array or a list. In Python, which we call list. Okay, so I would ask you to go to a link which I will be sharing with you. Wait, I will be giving you a link of the Python notebook, Jupyter notebook, and all you have to do is to just go on with me. Okay, so let me just post the link in the comments section. This is the Can you see the link which I shared just now? Thank you. Yeah. So, hi guys, I'm back again. Say a hi. Hello. Yeah, so because of network issues, I can't really run the collab. So it's really sad. So I will have to just continue with the given presentation. So I guess last we talked about scalars. So what are scalars? Scalars are basically numbers which are being assigned to some variable, right? We when in Python or in C or in C++, we assign values to variables, right? I mean, we write A is equals to 5 or B is equals to 42. So what are they? They are scalars, right? Vectors are nothing but arrays, row major or column major, it doesn't matter, but they are basically arrays or list, what you call as in Python. Okay, so scalars and vectors are very simple. If you have been coding in Python, you must be knowing these things. These are very basic. So next I will start with matrices. So what are matrices? Matrices are a collection of numbers organized in rows and columns, right? We see a 3 cross 3 matrix or 2 cross 2 matrix, right? So I will begin with matrix addition. So what do you think is the basic prerequisite of matrix addition? So there will be a little lag because of my network issues, and I will be waiting for your answer and then I will again start speaking. Okay. I guess there is the question is that what is the basic necessary and sufficient condition to add two matrices? Okay, means what is the basic condition which we need to fulfill so that we can add two matrices? Okay, two matrices must be of the same size. Yeah. So the very basic prerequisite is that two matrices will be of the same size, such that the number of rows of the first matrix must be equal to the number of rows of the second matrix, as well as number of columns of the first matrix must be equal to the number of columns of the second matrix. Right. So what we do here is that we add the numbers of the same position of the respective matrices and put them into the resultant matrix in the same position. For example, we add 1 and we add 11 and put them into, and the resultant is 12, and we put them into the same position, which is if this position is 0 0, this position is also 0 0, it gets added up to 12, and it got also set it also sets in the same position of 0 0, right? So this, I guess, most of us know about matrix addition. Then comes matrix multiplication. So what do you think is the necessary and sufficient condition for two matrices be multiplicable? Like, what condition which we must follow so that we can multiply two matrices, like we can multiply A and B? I'm waiting for your answers. Okay. So row 1 is equals to column 2. So the necessary and sufficient condition for two, yeah, correct. The necessary condition would be the number of columns of the first matrix must be equal to the number of rows of the second matrix, right? And how is multiplication performed? 1 is multiplied with 11, 2 is multiplied with 14, 3 is multiplied with 17, and the corresponding numbers are being added and saved, right? Saved as 90. Similarly, 4 gets multiplied by 11, 5 gets multiplied by 14, and 6 gets multiplied by 17, and the resultant becomes 216. Row of 2 is equals to column of 1. Yeah, that's correct, definitely. So this was the very basic matrix multiplication. I think this was understandable. Any questions till now? So I think I must move on now. Okay. So now I will be working with images, right? So there's a difference between there's a difference between image what we see and what computer sees, right? What we see is maybe a table, a chair, a bird, a dog, a cat, but what computer sees is a bunch of matrices, right? Is a bunch of numbers, which is basically a matrix. A computer sees an image as a matrix. If it is a black and white image, it sees it just as just a single matrix. But if it's a colored image, then it sees a image as a sequence of three matrices. I guess this will be covered in upcoming lessons, so I will not go deeper into this. Given that the matrix shown here is completely wrong, it shows all zeros, which is absurd, I guess. So next I will move to filters. Okay. So what is filtering? Filtering is the process of enhancing a image or changing its properties, basically, right? So, where is the utilization of filters? Filters are used for many applications such as removing noise, sharpening, smoothing, edge detection. The more you will go deeper into computer vision, you will start using filters more and more. They are many a times used as a pre-processing step for images, right? So how do filters work? Filters are also basically a small matrix which when convolved with the given image matrix, it produces some different properties of the image, right? For example, if I take a sharpening filter and apply it on an image, so what it will do, it will sharpen the image, right? So the operation which we perform here is convolution. Okay, so I will give a very basic introduction to what convolution is, right? So before going to what how this convolution is performed, I would like to introduce you with two properties of it. One is stride and the other is padding. So, what is stride? Stride is basically the amount by which we are shifting the given filter matrix, right? So, it says the logical memory address distance between two successive pixels of the image on a given axis. So, what it comes down to a point is that the amount we shift the smaller uh, kernel or the filter matrix is called stride. And what is padding? Padding is the extra zeros which we add on the edges of the given image, so that we can avoid overlapping of the so that we can avoid the effect of one end of the pixels to the other. You can read about it on the internet that why padding is important. Mostly padding is necessary so that pixels of one corner doesn't interfere the pixels of the other corner. Once you will understand how convolution is done and just read on the internet about why padding is important, right? So any questions till now? Then I will move to the operation of convolution. Okay, I don't think there are any questions. Just move on. So what if we have too much padding? How do we know the right amount? Look, padding is, I guess, mostly dependent on ourselves, the amount of padding which we I will be again explaining convolution. I will be explaining convolution in details. Okay, so don't worry about that. Okay. Convolution. Right. So, okay. So, what is convolution? Convolution is basically the process of multiplying two matrices, but this is bit difficult, different. So, how it works is that we take this matrix and we place it in the given image matrix. Say matrix, and I take this filter matrix and I place above the given image matrix, right? So what happens when we place the filter matrix above the image matrix? 0 places of 100, minus 1 places on top of 102. So this complete matrix, 3 cross 3 matrix is getting placed on above the smaller 3 cross 3 matrix. Okay. So what operation do we perform? So the operation is performed such as 105 is multiplied with 0, 102 is multiplied with minus 1, 100 multiplied by 0. Instead, the other number is multiplied by the numbers of the filter matrix, right? Right. So the complete matrix gets calculated. Okay. So what happens after we multiply 105 by 0, 103 by minus 1, 101 by 0, and all of the numbers? These are they are summed to form a single pixel, the resultant matrix. I would like to show you this image, which is from image kernel. You can see it over here, and you can just go to this link, and I can. This is a very example of what convolution is. Okay? So you can see the this left, there is red three legs, okay. You can see it's the